or semi-formal?
Semi. Wait. Okay. No jeans. All right. So you guys, I didn't fill out any of my papers because I was writing on the board. But we were working on even and odd identities. And I reminded you, it was a way back reach. It was chapter 1 of first semester, where an even function and an odd function, which you don't really need to know. So we said that sine of negative x is equal to negative sine x. Did I give you cosine? Okay. So cosine of negative x is equal to cosine of x. Tangent of negative x is equal to negative tangent x. That negative did not come through real well, but it's negative tangent x. So that means that sine is odd and tangent is odd. Cosine is even. So then cosecant, because you got to know all of them. I don't know why I put x in there. I'm really sorry. It should have probably been theta. Whatever. Cosecant is negative cosecant. Secant is secant of positive x. And cotangent of negative x is negative cotangent x. Now, while you're writing those down, I'll let you know what we're going to do today. So today we're going to talk about how you could use, especially these identities. Of all the ones that we wrote down on Friday, this is the one that I think might be useful for actually doing things. Otherwise, there's shortcuts to go around the other ones that I will remind you of. I've already talked about one. And then we'll talk about what are we actually going to use this for, because we will use these. So let me talk to you about using even and odd identities. Now, I want you to know that this is optional. You do not have to do this, but it is a shortcut. So I'm going to put optional. I already have taught you how to do these things, but this is just a potential shortcut. So let's say that I asked you to find the cosine of negative 7 pi over 4. Okay, we did one like this on our warm-up. It was we had a different fraction on the warm-up, but same idea. Negative 7 pi over 4 is not on the circle. Okay, there's no negative numbers on the circle. Okay, so if we were going to do this, we would have to figure out that we're adding 8 pi over 4, and we would have to add it, and then we'd have to find the cosine of actually pi over 4. These identities tell me that the cosine of the negative angle, the cosine of the negative angle is equal to the positive thing. So this is actually equal to the cosine of 7 pi over 4. No need to find the coterminal angle. Okay, so then I could just go to my paper and be like, oh, cosine is x, 7 pi over 4, that's square root of 2 over 2. Okay, so like, for example, let's say I asked you to find, let's go for the sine of negative 225 degrees. Okay, negative 225, not on the chart. So you have two options. You could add You could add 360 and do the whole coterminal thing, or you can use this identity that says, oh, the sine of a negative angle is going to be the opposite of the sine of the positive one. So 225, the sine of that is negative square root of 2 over 2. But it's the opposite of that, so it would make it positive square root of 2 over 2.
So this is just like
a shortcut. Now, I will say it's fairly limited because, like the other example that was on our warm-up was the tangent of negative 480. Well, guess what? Positive tangent 480 isn't on there either. So not helpful. You still have to add 360. So that's why it's optional. Like I've given you a way to do these. That's really not super hard. But if you remember it's there, it's not a dot. Okay, so that's why it's optional. Use it, don't use it. You're not gonna hurt my feelings. You're not gonna get anything wrong unless you do the other math wrong. Okay, now I want to remind you, this is a little bit of a way back review. We did this though. So let's say that we know that the sine of an angle is 4/5, and I want us to find the cosine of that angle. Okay. So we have done this. This is not a mystery. I mean, you might not remember it, but we did do it. In this kind of a situation, you're breaking sine down. You're not looking at as it 4/5 as one thing. You're looking at as opposite over hypotenuse. So sine gives you two things. Sine gives you opposite and hypotenuse. So if I wanted to do this problem, I would make a triangle. I would label his opposite and his hypotenuse. And if I want to find the cosine, then I would use Pythagorean theorem to find the bottom. Okay, or you could remember that this is a Pythagorean triple, and what's the other number? 3. 3, 4, 5. Either way, it's Pythagorean theorem, so whatever. Now it's super easy to find the cosine. What's the cosine? 3/5. You guys, this is the way that I would do it. But let me tell you this. You could use the identities. I'm going to put a star here because this would be my preferred way to do it. Like literally, I know how to use the identities and I never do it the way that I'm going to show you. So let's say we're going to go same problem. Sine theta equals 4/5. Find cosine theta, but we're going to use the identities. Okay, that means we're using everything on that pinky purple paper. Okay, so there's one of these identities that you have that relates sine and cosine. That relates only sine and cosine, and it's the big dog. Okay, big dog says that sine squared plus cosine squared is equal to what? 1. So because you know sine, you can find cosine because those are the only two pieces that you've got there. So again, what we talked about Friday, sine squared means that you take the sine and square it. This is cosine squared. Okay, we talked about that. If you look in your notes, if you were taking decent notes, I said it's written with the squared next to the sine, but it's used parentheses and the square is on the outside. Now you have to remember how to square fractions if you're going to do this. It's one reason. I mean, I can do this just fine, but who wants to do that when other ways easier? When you square a fraction, you're squaring the top and the bottom. It's 4/5 times 4/5, which is what? 16 25ths. Okay. Now we got to figure out what cosine squared is. So we got to subtract. This is a good news, bad news situation. Like I said, bad news, I would never do it this way. But good news, if you're ever doing something that involves 1 with your common denominator, it's super easy to turn this into a common denominator. What is the 1? 25/25. That's got to be your denominator. Work backwards. It's got to be 25/25. Okay, so this is cosine squared. Fraction subtraction is top minus top, bottom minus, or not bottom minus bottom. Top minus top, keep the bottom the same. So 25 minus 16 is what? 9. 25 stays the same. This is cosine squared. I don't want cosine squared. I want cosine. So how do I do that? Square root it. Yep. And then you square root the top and you square root the bottom. So that's square root of 9 over square root of 25, which is what? 3 over 5. Now, I just want you to compare the amount of work. Okay? This, to me, is goofy when I can do it like this. Okay? This makes it. Okay? This is opposite over hypotenuse.
Yep.
So I drew my triangle that way.
Yep.
Opposite hypotenuse.
Yep.
I didn't know what this was. So x squared plus 4 squared equals 5 squared. Pythagorean theorem. 25 minus 16 square root 3, and then I know the opposite side. So you can either do it this way or you can do it this way. This one is much more versatile because I could ask you to find anything. I could be like, hey, find the cotangent. If you had to use identities to do that, you'd have to find sine and cosine, and then you'd have to use the other identities. It is a freaking mess. Okay, so trust me, this is the easiest way to do it, which is why there's a star there. So that's what you could use it for, both of those things. Now we're going to talk about what are we going to use this for. For what?
Like all those steps at the end, like the fraction stuff.
Other than the fact that this would probably say exact value, so you'd have to keep it in fraction. What? Yes, we do. If it works. But what if you have some terrible fraction that doesn't work? Or you had to round in between, which is, again, why I would say just make the triangle and call it good. Okay, so here you go. So we're talking about how we are using this is in proofs. So let me remind you, you don't have to write this down. Let me remind you, in geometry class, do you remember proofs in geometry class? Okay, most people hate them.
Oh, I do.
Okay, so don't write, like I said, don't write this down, but a geometry proof would look something like this, where it would say like ABC
You have to
and
like list the rules for Y.
for Y, right? So like this might say, triangle ABC is isosceles, and BD is a perpendicular bisector. And then you might be asked to prove that AD is congruent to DC. Okay, so in a geometry proof, it's a table, and you have to give a statement, and you have to give a reason for everything. And you start out here, you write, this is what's given, this is the other thing that's given, and you start making statements that go from that. Okay, these proofs are not like that. Okay, I'm not a fan of these. I can do them. I still like teaching people to do them because people don't know how to think, especially sophomores. These are much different. Okay, I very much like these. They are all algebra based. All algebra based. You don't have to give a reason for anything. You just have to make sure it's algebraically correct. Okay, so these are not saying that they are necessarily easy, but they're not geometry proofs. Okay, so I think they are.
Are they less writing?
Yes, much less writing. There's also no givens like that whole setup. You don't have to do it that way. Very different. Okay, so let me give you a couple strategies. 5 strategies actually. These are not in any particular order. So as I talk to you today, I'm going to tell you how you know which of these you might want to do. So I will embed that in what we're talking about today. So the first strategy that I'm going to talk about is turn everything in terms of sines and cosines. So turn everything into sines and cosines. Okay, let me give you a second to write that down. So Jack's making 4 choices. So if you look at this, the quotient identities, what? Please sign out. The quotient identity tangent can be rewritten in terms of sines and cosines. Cotangent can be written in terms of cosine and sine. Over here, cosecant can be written in terms of sine, and secant can be written in terms of cosine. So I have those starred on mine because those are the four that you use for this. So when you're turning everything into terms of sines and cosines, those are the four that you use. Okay? Because it gets rid of tangent and cotangent, cosecant and secant, and makes everything in terms of sines and cosines. Okay? We do this if we can cancel. Okay? So the purpose of this is so that you could cancel potentially something, which I will show you. The second thing, not in any particular order. For a second, I gotta find my notes because I can't remember how I said this. You are allowed to rearrange and or substitute anything on the purple sheet.
Do I have to write you are allowed or can I just say I'm allowed?
I don't care, it's your note. Your notes. Okay, so that means that anything on here, anything that is on this paper, so you cannot just make up something, but anything that's on this paper, you can rearrange it and you can substitute. Okay, especially, I'm just going to say this, especially the dogs. Okay, and again, I will tell you how you know when you want to do this. I will say this, you want to do this pre-distribution. Never mind, I'm not saying that yet. I'll just talk about it as I go. I'm struggling with my paper. There. Okay, don't be afraid to distribute if that's an option. Do any available algebra. Basically, that's distribution. It might be factoring, which we will get to. Not today, because that's more advanced. It's okay. And the last thing is that there is definitely going to be some things with fraction math. But don't freak out, because most of the time, it's a common denominator and you're dealing with a 1. So those are easy to come up with common denominators for. Okay, so let me give you the first example here. It's going to look like a little foreign language-ish. Make sure you listen to me. I do not expect you to know how to do this after the first 5 examples. Okay, so keep an open mind. A couple things that are good things.
How many lines roll?
3, 4. Okay, so the first thing is that if it says prove that something equals something else, it has to work. Okay, it has to work. There's no sneaky business in this where, oh, you gave me something and it doesn't work. It has to work if it says prove. Okay, it must. Now, the thing that you need to know, the most important thing is that you can only touch one side at a time. And I don't even want to say one side at a time. You can only touch one side and you cannot cross the equal sign. Okay, you can only touch one side and you cannot cross the equal sign. Those are the 2 main rules. Okay, so here's the first thing. You have to decide. Since I can only we can only touch one side at a time. You have to decide. Do you want to turn cosine secant into 1, or do you want to reverse engineer 1 and try to get him to be equal to cosine secant?
I'm gonna ask you to tell me.
You always want to go with the one that has more options, which would in this case would be the left-hand side. Okay? I don't even know how I'm going to magic up anything that's 1 that's going to be helpful. You go with the side that you could actually do something with. So the fact that I look at this and I go, those are multiplied, tells me that what I want to do is turn everything into sines and cosines. Okay? Because where there is multiplication, there is the opportunity to cancel something. Doesn't always happen, but there's the opportunity. So pick the left side. We're going to work with the left side. We're going to turn everything into terms of sines and cosines. Well, also a nice choice for us because this already is a cosine. Okay, but secant, what is secant defined as from your paper? 1 over cosine. Now, I'm going to tell you something and half of you will ignore me. And later, when we're practicing this, I will say to you, remember what I told you to do with your fractions. If you're turning things into fractions, put a 1 under this cosine to help him keep his spot. Okay, so if it's not already turning into a fraction like that secant, give him a 1. Otherwise, they end up sinking and you are like, I can't cancel anything because it's cosine and cosine. And yeah, because that cosine's supposed to have a 1 under it. It's on the top. Okay, so this is where life gets really good. What are you allowed to do with this? Or what can you do? Yeah, you can multiply that, cosine over cosine, or if you want, you can be like, hey, those cancel. Now it's 1 over 1, same thing. So it's the same thing. What's that equal to? It's equal to 1. And I just hit the target. And I'm done.
Wait, that was easy.
Correct. Okay, so listen, this is like the target. Okay, so you can't do anything with it. It's just there to tell you what the left-hand side has to equal. Okay, so when I tell you, like, you don't have to say anything about your steps, you don't, because it's all algebraic. You can cancel, you can substitute without telling me what you did. Okay, so let's try this one. So this is tangent theta times cosecant theta is equal to secant theta. No, it's only one O. PROOF is proof, and proof is only one.
I tried to mix.
Yeah, I know it looks funny because you look at it and go, oh, doesn't quite look right. Okay, so again, multiplication lets me know I should probably turn things into terms of sines and cosines because hopefully something will cancel. I wouldn't touch the secant because how am I supposed to turn them into that? Okay, so if it's multiplication, turn everything into terms of sines and cosines. So what is tangent in terms of sines and cosines? Sine over cosine. Guys, that's the quotient identity. What is cosecant?
1 over sine.
1 over sine. Okay, now it's all about simplifying and canceling. So what can you simplify or cancel? Okay, so listen, I just want to explain why. Because this is a sine over this is a sine on top and a sine on the bottom. So if I pulled those two pieces apart, it's a sine over a sine, which is equal to 1. So I can cancel them. 1 on the top, 1 on the bottom cancels. Now, this is not 1, like the last one was 1. What this is 1 over cosine, though. That's what's left. And that is equal to secant. It's actually, like, you can laugh at me. It's only math cool. But when you can see where it's going to go, you're like, I got this. It's kind of a good feeling. Okay. One of the things that I want you to understand, this is important, okay, and people are going to argue with me. They did last year all the time. This has to be absolutely identical to this side. So what I have on the left side, the side I'm working with, must be identical. So don't stop here. Okay, don't stop here and be like, oh, well, hello, you know that's equal to secant. For proofs, you literally have to have right side and left side equal. They have to be visually, functionally equal. Okay, just don't stop. That's all I'm saying. Okay, let's try another one. So let's try, plus. Yep. I'm not done. Okay. Don't complain. We're going to be doing proofs for a long time. Okay, now I want you to write it down and I want you to listen to me. Okay. Two things multiplied together are what lets us cancel. Right now, do I have any trigonometry thing times another trigonometry thing that might cancel? The way, I just pause that. The way it is, there's nothing connected to each other by multiplication that can cancel. Okay? Therefore, I don't want to turn everything into terms of sines and cosines. I only do that if I can cancel something. Okay? So, what would you do with this? What do you want to do? It is that one thing. Okay, you're going to get where you're going, but you need to distribute. Okay, this multiplies just like anything else you would distribute. So if you want to do boxes to distribute, you can. I'm just going to talk you through this because. Okay, this is secant theta times secant theta. Secant theta with the th. So it's secant squared. Okay, no, not secant. When you multiply these guys together, you literally just smush them together. So this is minus secant theta times the tangent theta. Okay, the negative should go in the front because that's how you do it. Okay, and then do this guy. This is tangent times secant, so that is what it is. Hang on. Hang on. Don't you steal anybody's learning moment.
Why is it minus secant?
Because this is a secant times a negative tangent. So this is like a -1 is what it is. So it's a secant times a tangent and a -1. So negative secant tangent. Positive times a negative. If you want it a different way, it's a positive times a negative. Okay, last one. Negative tangent squared theta. Okay. Now, before, again, now you might be like, hey, I got secant tangent and secant tangent. I could turn those in terms of sines and cosines. You absolutely could. But look at what's there first. They do cancel, which is where Ace was going. If you caught the fact that these are conjugates, that's the word you were looking for. If you caught the fact that these are conjugates, it's only the first one and the last one you have to multiply anyway. Yes. So you were here. Okay? Secant squared minus tangent squared. So here's the deal. This is, I think I put it as number 2, but I'm not sure. You are allowed, in order to make things equal or to prove that things are equal, you may rearrange anything on that pink sheet. Okay? You rearrange anything. So when I see some things squared with addition or subtraction, the first place I'm going to go looking is at the dogs. There is a little dog. So that little dog says, I'm just going to write it up here. Okay? Tangent squared plus 1 is equal to secant squared. Okay? That's the dog that relates tangent and secant. So the thing that you want to do, we want to be able to substitute can I do something to what I already know is true? That's this identity. Can I do something to make it be secant squared minus tangent squared? I can subtract the tangent. Okay, you don't have to write this down. You can do it in your head. I'm totally fine with that. But by rearranging this, I can see that secant squared minus tangent squared is equal to what? 1. And guess what? Now I'm done. Because that's what the target was.
So I could just go from secant squared minus tangent squared and then just write equals 1.
Yes.
And I'll get all my points.
Because it's algebraic and follows one of the rules that I gave you.
How often do people just like equals 1?
All the time.
She hasn't checked.
Yeah, you wish. Okay. So this is the only step of this that you could get rid of is that first one, because if you caught that it was the conjugate, you would go right to this and then you'd be fine. Okay. So let's try this one.
Fairly certain that
Okay. That's cosecant plus 1 and cosecant minus 1. Cosecant plus 1, cosecant minus 1 equals cotangent squared.
it's another conjunction.
Conjugate. Sorry, it took me a minute you got me way off with conjunction, and I was like, what is that word? Conjugate.
Is that not like a math thing, conjunction?
There is a math thing but it is mostly an English thing. There is a math thing that's a conjunction. We just don't talk about it.
Is that like Cal 4?
No. It's something in pre-calc that we just aren't talking about. No, I lied. It's not. It's not a thing. I was thinking about different things. No conjunctions. Very good. So glad you know that song. Okay. Notice that we have another conjugate here. So you don't have to multiply the inside pieces. So what are you left with? Minus 1. Okay, we would like that to somehow be equal to cotangent. So listen, again, if I see ones and things squared, I'm looking for a dog. Okay, so this is the second of the little dogs. So 1 plus cotangent squared is equal to cosecant squared. But I'd like that to be equal to cosecant squared minus 1. Can it do that? Subtract the 1, right? What's that equal to? Yeah, cotangent squared. And you're done. Okay, now, before we go any further, because we are going to go further, what are your questions right now?
Are these test level?
No.
Oh my god, no. Are they even close? Are they like
This one might be.
quiz level?
The first two were not.
Question?
Okay. These ones are not bad. Okay, so next thing that I want to tell you is this is a little nerdy mathy, but I'm telling you anyway.
Little nerdy mathy boy.
When you are done, I'm tell you this because if you go to college, this is actually a college thing. This is not on the level of big dog and little dog. Nobody will laugh at you if you say it. Traditionally, like from way back, QED is a Latin abbreviation. It's a Latin, 3 words. It's quo erat demonstratum. That's the Latin. And basically what it means is, this my translation is, hey, I did it. Right? I'm done. I got whatever that is. Cotangent is equal to cotangent. Done. It means, if you translated it literally, it means that which was to be demonstrated. So, hey, look, I did what you wanted me to do. That's what that means. You don't have to write it, but it's a really good indicator of, hey, I'm done. Mic drop. right? Done. Don't have to write it. I'm just giving you a little bit of trivia. And it is helpful for me, not, again, I don't care if you write it not. It is helpful for me to know though, are you done or did you just give up? Okay, because there is that. No. So that's a good question. Ezra said, can you just circle your answer? And the answer to that is no, because it's this whole thing, right? It's the process that you're looking for. Now, let me tell you this. Sometimes people are like, well, why do I have to know this? I'm never going to have to do this in my real life. Right. But you know what? This is all about teaching you how to think logically and in a progressive sequence of things. This is brain training is what it is. Okay? It's good for your brain. It's very logical and it's very sequential. Okay. This is our last one for today. We'll see how far we get through this one. Okay, so when Braden's done looking at his watch, do you want to work with the right-hand side or the left-hand side? This is a right-hand side. I don't know, a cotangent could be 50,000 things. I'm working with the right-hand side because it gives me the ability to maybe do some other things. Okay, so we have not talked about one like this yet. What I want to say to you is if there's anything fractional there, 9 times out of 10, you want to go with it. You already found it. Maybe. Let me pause and say this. There are also 2 ways to do this. There's probably more than 2 ways, so I'm going to give you both of them because it's really nice to know that there is more than one way to get an answer, and they would both be correct. So I'm going to show you the way that's actually a little bit longer first because this is what I want to do. This is a fraction. If I'd like to combine it with this fraction, they have to have a common denominator. What's the denominator? This sine squared. That's not rocket science there, my friends, because this is the denominator, right? So this 1 has to turn into what? Yeah, sine squared over sine squared. Okay, that's still equal to 1, logically an equivalent step. Now, the other thing about fractions, if you ever are working on a problem where you're like, hey, this has a common denominator, it's there for a reason, you should use it. Okay, so when you do the common denominator, remember, add, subtract the tops, the bottom stays the same. So this is 1 minus sine squared over sine squared because the bottom stays the same. And you'd be like, that does not help me. But it does. Because, take a look at the top. That is 1s and sine squared, which should in your brain say, what? Big dog. Okay? Or dog in general. Okay? And then you go, oh, the big dog has 1s and sine squareds. So the big dog is sine squared plus cosine squared equals 1. So the question is, if I can rearrange this to be 1 minus sine squared, can I? Yeah. I'm just too lazy to write out sine and cosine here, that's all. Sine squared minus sine squared. 1 minus sine squared is equal to what? So I am allowed to substitute out the top because that is equivalent to cosine squared over sine squared. Now, what is cosine squared over sine squared equal to? Cotangent squared. And you're done. Quotient identity. Cosine over sine?
Oh, those are all squared.
Yeah, no, they're not. But it's okay if you, that just means you got 2 of them, so you got 2 of them. So, Mawson, that's true whether they're squared or they're not squared. Okay, that's one way to do it. Now, guess what? That's actually the long way. Okay, so I'm going to show you the short way. Okay, so If I was going to do this the other way, Sam, what do you want to do? What would you do?
Can't you turn like the signs, the 1 over sine squared to like cosecant squared, and then that's the little dog?
This is equal to cosecant squared because, no, yeah, cosecant squared. Cosecant is 1 over sine. So this guy is cosecant squared. Okay? So cosecant squared minus 1, if you look back up in, I have it in my notes right up here, I know that that's equal to, I rearranged it, and it's equal to cotangent squared. And you're done. Okay? So listen, the nice thing about it is even if you didn't catch that, there's another way to get it. I have done problems like this where there are 4 or 5 ways to do it. Last year there was somebody that did something that I was like, I never thought of doing it that way. And it was genius. Okay. So you can come up with something that maybe I didn't tell you. If you're making a legal substitution from your pink sheet, you're fine.
Oh, perfect. They're salting right now. I love rust on my car.
Thank you for derailing everything, but we're done. So, tomorrow we will practice some more of these.